Hey everybody, welcome back. How's it going? So last time we looked at making the MSE, or the mean squared error function in NumPy, and it was a lot cleaner. And we're going to clean up the train parameters as well. And if you remember, there was a formula that I'm not really going to worry too much. It's going to be just a bit of a writing down for me, and you'll have to remember that I gave this formula. It's something that, I don't want to go into too much. It just happens to be that the answer is going to be x transpose x inverse x transpose y, and we're going to have to deal with that. So if you don't want to watch this video, honestly, it's okay, but know that we're going to make a train parameters function, and you should probably check out at least how I'm doing it, and I'll explain it after, but it's important to get the general flow of what I'm talking about here. So the important piece is that we're training the beta parameters to minimize the MSE, and so let's see how I can do that. Well, grabbing the function definition, we're going to make some changes for sure. So before we had just one long list of x's. Well, that's not going to do anymore because we have many different x parameters. Okay, we have x1, x2, and that's each of those, we have n of those things. Okay, so we have n x1s, n x2s, n x3s, and so on. And for the y's, well, that's pretty much the same thing, except instead of a list, it's going to be a vector. That's just the n different observed values. And params, well, we're going to make that again a vector. You could make it a dictionary as well, but it's more awkward because we used to be extracting out like this is beta naught, this is beta 1. I don't really want to do that. I just want to all in one transform the vector itself. So we're going to make this a matrix, we're going to make this a vector, and this a vector, and I'll explain exactly what now. So x's is actually going to be, we generally call it x, that's our design matrix, and so that is going to look exactly the same as it did above, and so I will just copy that down here. So x, okay, that's not right. X is a NumPy array with shape n by p. Okay, so we have n many rows, that's how many examples that we have, and p many columns. And again, it's going to have its first column all equal to 1s because that just makes it convenient for us. Now what we're going to do is the next parameter is the y's. Okay, so y's, we should have this above already. So y's, again here, I'll just write it out. Y's is a NumPy.array with shape n comma. Okay, so we have n predictions, and it just looks like that. Now params is going to be basically the same thing as beta. Okay, so I'm going to really just treat this, I'm actually just going to call this beta now instead. I might as well, because beta is a NumPy.array shape with shape p comma. Okay, so p many things in beta, n many things in the y's, y many values. We have n by p many in our design matrix. Okay, so now that we have that set up, don't worry too much about what I'm going to do here. I'm going to go off screen and put the formula here so you can see it. Okay, I got the formula here, and so really don't worry too much about this part, but please watch it. The important part is that we have, in this case, some particular formula that's going to give the beta vector, a particular set of values that minimizes the MSE based off of the data that we saw. That's the really important take-home message here, and the actual code here, don't worry about it too much. Okay, so a whole bunch of crazy stuff just popped in front of you. Don't worry about it too much. So basically what I did is A is the matrix multiplication, and we don't even really know what operation that is. Don't worry about it too much. A is the matrix multiplication of x transpose and the inverse of x. So that what I got is that this thing in here, that matrix multiplication, and I called that A. Okay, so then A inverse is just the inverse of A like that. That's how you do it in NumPy. And then A inverse times x transpose is this matrix multiplication there. That's this part, which is also this part. And then we can do the dot product, and actually it's not really a dot product, it's actually a matrix vector multiplication, even though it's called dot, and that gets the last piece there, and we can just return that. So don't worry, the important part is that there's a formula based off of our data that we observed that we can absolutely minimize the MSE that we got. I also just realized now that since we're not using a dictionary, we really don't need to actually pass in beta at all. That's an important one, which trains our parameters, understand the general feel of it, and as long as you're good to go there, I will see you in the next video.